afternoon again. Hello, my followers. Don't forget to click subscribe, the notification sign, and to click like and share to your friends, students, and parents to follow the exercises and the answers, questions and answers. Today, we are going to discuss about the chemical equilibrium. The chemical equilibrium we are dealing with is a type of dynamic equilibrium. Dynamic equilibrium is when the rate of forward process and the rate of backward process are the same in equilibrium in a closed system. On the point B of this question, we are going to deal with the Le Chatelier principle. In the Le Chatelier principle, that thing that we are going to deal with is to see what happens if you take a given amount of a substance which is present in one side, how the position of equilibrium is shifted to the side, to the left side or to the right side. When it is shifting to the left side, we can say that the backward process is favored. But if it is shifting to the right side, we can say that the forward process is favored and it is increasing the yield, but in backward the yield is decreased. For this purpose, we can continue to see an example of the equilibrium by calculating, by using exercises. In chemistry, we understand the rationale of the concept by using calculations, by using examples, by using exercises. After this application, we can understand more the concept that we are dealing with. In this case, we have the question of the which is about chemical equilibrium. The first question here, point A, is saying antimony pentachloride dissociates in antimony trichloride and chlorine. At 180 Celsius degrees, it was found that it is dissociated to 29.2%. Calculate Kp and Kc for the dissociation at this temperature. If we started with 2 moles of antimony pentachloride or SbCl5 in a container of 1 liter, relative atomic mass of antimony is 122. For chlorine is 35.5. For B is where we are going to see how the Le Chatelier principle is applied. On B, because we place 10 grams of SbCl5 in a 5 liter container at 448 Celsius degrees and allow the reaction to attain the equilibrium. How many grams of antimony pentachloride are present at the equilibrium? Solve this problem. I Roman 1 using Kc and molar concentrations. I2 Roman 2 using Kp and partial pressure in the partial pressures at 448 Celsius degrees. Kc is equal to 2.51 times 10 negative 2, and Kp is equal to 1.48. Now, let's see the answer of this question. But now we are starting by question number 1. We have the data. The data we have here. We have the first of all initial number of mole. What we call initial number of mole. Initial number of mole is equal to 2 mole. 2 mole. It means that for 2 moles is the number of mole of antimony pentachloride. But here we cannot for this we cannot forget to write the equation. To write the equation, here we have to write the equation. Antimony pentachloride is dissociated with equilibrium to give antimony trichloride with chlorine. For this purpose, it means that antimony pentachloride, which is given antimony trichloride and chlorine gas, here we are going to use the approach. This approach is called the Rice table or ice table. Now the table means R means reaction, I means initial, C means change, and E means equilibrium. Then for R we have the reaction. The reaction here is antimony pentachloride dissociating to antimony trichloride with chlorine. Then here we have I. For initial we have 2 mole, but here we have 0 because at the beginning we don't have any number of mole of on the side, on the right side. But when there is a change, some amount is removed. The amount which is removed here is the amount which is removed, there is the remaining at equilibrium. At equilibrium, we have 29.2%, and 29.2% is equal to 2 times 29.2 over 100, and this will equal to 0.584 mole. Means that the remaining, it means that 2 moles minus 29 minus 0.584, we have 1.416 mole. This is what is changed, because if we subtract 1.416 mole from 2, the remaining is 0.584. It means that on a chain there is negative 1.416 mole. But here, what is subtracted here? Because if we respect stoichiometric coefficient, here we have 1, means that here what is subtracted here, it is added here 1.416, and here there is plus 1.416, and the remaining at the equilibrium will be 0.584, and here it is plus 1416 here plus 1416. Those are number of mole, and the table we have here, is what we call Rice table. Is called Rice table. This is the Rice table. Rice table. Initial concentration. Then after having this, we know that Kc will be equal to the concentration of the species which on the right side. Here we will take concentration of SbCr3 and the concentration of chlorine over the concentration of antimony pentachloride. Then by calculating, you know that molarity, which is molar concentration, is equal to number of mole over volume. The fact that volume is equal to 1 liter, the numerical value is not changing. It means that the number of mole we have here over 1, it continues to give the same numerical values. It means that Kc in this context, it will be equal, because the number of mole are the same. It is equal to 1416 times 1.416 over the concentration that we have on this side, 0.584. In this case, we can say that Kc is equal to 1416 squared over 0.584. For this reason, we can see that if Kc is equal to 1.416 squared over 0.584, and it is equal to 3.4. It is equal to 3.43 m. This is Kc. By using relation between partial pressure and molar concentration, we know that pressure is equal to, total pressure is equal to the molar fraction. Mole fraction is equal to, partial pressure is equal to the molar fraction times total pressure. Then by using the formula, we know that Kp is equal to Kc times RT delta N. In this context, because the concentration is expressed in liter, in mole per liter, it means that R will use the constant of perfect gas, the numerical value which is expressed in liter. It is 0.0821 liter in atmosphere, liter mole minus 1, and the pressure will be expressed in atmosphere. For this reason, we are going to find Kp when we take Kc times RT RT, it means that 0.0821 times the temperature. But here, temperature is equal 180 Celsius degrees equal to 180 plus 273 plus 273. This is Kelvin, is equal to 453 Kelvin, and in this case Kp will be equal to 3.43. This is Kc times 0.081 times 821 times 453 power delta n. What is delta n? Delta n, but what we have to understand is that what we have to understand in the equation that we have started with is that here we take forward minus backward. Here there is gas, and this is also, it is a gas, not a solid, gas. At the gaseous state, the product, number of mole product minus number of mole by using stoichiometric coefficient at the gaseous state, it gives delta n. Means that delta n is equal, delta n is equal to 1 to 2 minus 1 equal to 1. Means that delta is equal number of mole of the product minus number of mole of reactant, but at gaseous state. Then find that delta n in our question, it is equal, it will be equal to 2 minus 1 equal to 1. Then Kc is equal, Kc will be equal, Kp will be equal to 343 times 0.0821 times 453 power 1. You know that if a given number is the power 1, it means that nothing will change on the power. It means that we maintain the same number. Kp will be exactly equal to 343 times what we have here without putting the power, because the power here is 1, the power here is 1, and if the power is 1, it means that we have to multiply 0.0821 times 453. And here we find that it is equal to 127 atmosphere. This is Kp. On B, I ask you to subscribe, because here I can say see you next. Please click subscribe, click the notification, click like, and click share. See you next for the answer on B by application of Le Chatelier principle. I encourage you to continue to follow those exercises. Thank you.